other, that's right, but I'm saying in the inner parts of galaxies, stars usually dominate the mass. You don't have much dark matter.
For the inner part.
That's true, and we've actually.
So that's what we are observing.
But also the stellar
that's been a big
mass depends
result
on the
recently.
reddening. You've got to get a mass to light, so they're doing the reddening more or less right, and probably
You mean
the outliers.
I just
are
want to
probably
be
the
impressed by the theoretical features. I
No.
don't see anything.
You're supposed to be impressed by the data.
Yeah, as I said, I came here as an observer, understanding that
The
I'm
fact that they
talking.
can measure this is
No, but
remarkable.
TNG, what I'm saying is TNG doesn't give you extra information in this plot.
No,
It's just to validate.
it's developed. It's to make sure that. Well, I guess maybe we're on the same page on this, right? I mean, to some extent, I want to know that if I go into the simulations and I try to reconstruct stuff from and try to say, okay, well, here's the information I get on various star formation histories or dynamical masses or where stars came from, that I have some confidence that maybe I'm getting some useful information from. No offense to the people who are doing theory, by the way, but I mean, as an observer, because it's been all over the place, right? This wasn't the case 10 years ago. 15 years ago. So, if I'd done that, it wouldn't have gotten me anything useful. And the whole point for me was basically to say, okay, it seems to be okay, and who knows if it's actually really, really right, but it seems to match reasonably well with the observations. And so that means that I can go in and actually go and reconstruct something. So I'm not trying to, I don't know, I'm not a theorist. I think you guys can tell by now, right? I'm not a theorist. I'm not trying to convince you that Illustris is the best thing ever, but it did work well with our observations, and we had a team of people who were working with them, and it helped us actually interpret the theoretical predictions and actually compare them to the observations, which is very challenging. I mean, just trying to get a size. Oh my God! Like, how do you get a size of a galaxy from observations? Because we know, for example, that we're underestimating the sizes of galaxies. By how much? How much? Yeah, exactly, right? Right, so.
Well, I'm very impressed by the observation.
Thank you.
Saying, you shouldn't give too much credit to the theorists.
Well, they do
I mean, it
see a
didn't have to
difference
match, though, right?
between redshift 3 and redshift 2.
Of course they would.
All right,
Any simulation that has the wrong physics would match this plot. Because the amount of mass in stars is the amount of light.
It doesn't have to be that way, though.
Okay, there was, all right, I'm gonna take the person behind Charlie, who had a, yeah.
I have a question about your very finely sampled SCDs. I feel like that's super remarkable, how much information you have. And I feel like all of those emission lines that appear as small bumps, I feel like that's very challenging interpreting. So I just wanted to hear a little bit more on how you did it technically, and how often can you are you in kind of danger of confusing just some random
Yes.
data uncertainty
So Ben, picture here, actually tested extensively how well you could recover the emission lines and the bumps and the wiggles. And to be fair, Charlie also did some really fine work. Finally, you were trying to measure 2800, this magnesium feature with Mariska, which I don't even understand how you did that. But it is possible to. So when Ben was doing his testing, he at least from the composite SEDs, from these, not the individual galaxies, but the composites, he was able to confirm that he could measure equivalent widths down to 20 angstroms, which is sort of shocking. But yeah, so definitely that was quite impressive. But in terms of the bumps and wiggles, you do. I mean, the problem is here with H alpha, it's blended with this other feature next to its N2. So we can't, so what you can do is you can fit two Gaussians and you say, okay, well, I know where they're supposed to be, and then I know what the spectral resolution is. I can fatten them, and then I can just add them on top of the SED and then just pull them out. So it's something similar to what we do with photometry, for example. With photometry, you have different wavelengths, but then, one image, the seeing is worse, and then the other one, the seeing is better. So what you do with the better seeing is when you can see two objects, you know where the two objects are, and then you add flux, and then you blur them together and try to reconstruct the poorer seeing one. But yeah, so he did a huge amount of work on this. He looked at things like certainly morphological properties and a little bit into starburst work, tons of stuff that I'm actually out of time, so I didn't have a chance to cover. But I think if you're interested in this type of work, definitely talk to me and definitely look at his papers because it's very thorough and detailed and well explained.
So can you go to
Abby, is it? It's not.
Just the after, I think that was just like the last one that you posted.
Alright. Is it?
Fantastic job of like using the
sorry.
TNG data. Just go
Oh, more? Okay.
just toward the end of the.
Sorry. Everybody gets to see the talk again. Sorry.
Good reminder.
Yes, it's good. Good flash. You mean this one or?
No, the other one afterward.
Um,
Yeah, sorry.
you mean this one?
Yeah, and then the other one.
This is the one that says-
No, the last one.
Okay,
Sorry. Yeah. Here, right.
Yes.
And another mass that was just higher.
Yeah, those are high
Right.
mass
So
galaxies.
it seems like that actually, it seems like that, you know, ex situ star formation is not only correlated with the mass of the star, but also to the ellipticity and the age of the actually, you know, host halos according to one of the other TNG paper. So since you're observer, I was wondering,
Okay.
can you use your great observation or, you know, a kind of like data to talk about the ellipticity of these galaxies or the age of their halos or whatever?
So no, I think in short, no. I mean, I could, but I mean, I wouldn't believe myself, and so I probably wouldn't. I mean, explore that. So to be fair, Anshu is now working on the follow-up paper where she's oh yes, here.
Remember some percentage, you can just like discriminate this in terms of like how your galaxy is actually shaped or whatever.
I was trying to. Oh no, I thought I had a different. Oh, I forgot to add it. So Anshu is actually looking into the size growth of these two samples of galaxies. This one here.
Yeah.
And she's using IllustrisTNG to look into that. So what she finds is that there are these big diffuse galaxies that that grow, their sizes grow differently compared to a different subset of galaxies. That was not particularly articulate, but she's looking into that. I can show you some plots later.
Okay. But from the data at these high redshifts, can you find the ellipticity of the shape of the galaxy? You can monitor it?
So we do measure elliptices and sizes and morphologies, but I don't. Oh, I didn't actually show you any images. No, I mean yes, sort of, but yeah. I think this is always for me the really illustrated gap between observers and theorists. So especially above the local universe, and even with HST imaging, there's really not. I mean, you can measure like axis ratios fairly confidently, and then you can convert that to an ellipticity. But that's just the light that you see, right? You have no idea. And that light, depending on your wavelength, could be just dominated by young stars, which would be distributed very differently. I mean, if you look at the Milky Way, right? If you look at the O and B type stars versus, say, the K giants and stuff, they're distributed very differently. And so we're really limited by interpreting the light.
4 pixels.
It's a very unsatisfying answer, but
Thank you so much, Dee. Let's thank Fee again.